Hello and welcome to my YouTube channel, amazing people, students, and you all who engage with the stuff that I put out here. I'm super excited to be here with you on today's episode on this series where we've been learning how to balance chemical equations. Now it has built up to this crescendo, and today we're going to be going full length into the art of balancing chemical equations. We're going to be seeing the step-by-step strategies that you need to be acquainted with when balancing chemical equations. So without any further ado, let's get into what we have for today's video. So let's start with the basics, one step at a time. Alright, now balancing chemical equations at first can look scary because it's just like learning to ride a bicycle. At the first instance, you're tempted to look at the pedal while you're trying to move forward. You fall, you rise, you fall, you rise. But the thing is, once you can break it down into simple steps, it becomes like solving a puzzle. So we're going to be taking those steps one after the other until you become a pro at the art of balancing chemical equations. So let's see each and every one of them step by step. So the first thing to do when you want to balance a chemical equation is this. Before you even say you want to balance anything, you need to make sure you know the correct formulas of the reactants and of the products. Because let's face it, balancing a chemical equation involves you utilizing symbols and formulas. So if you do not know the right formula of a product of a reactant taking place in a chemical reaction, you will be disarmed and unable to balance the chemical equation. So for instance, now if I say hydrogen reacts with oxygen to form water, and I ask you to write out the formulas of each and every one of these. If you didn't know the formula to start with, then balancing the chemical equation will be impossible. But someone who knows the formula will just go ahead and write this. H2 plus O2 will give us H₂O. So that's the first step. You need to be acquainted with how the formulas and the symbols come into play. Now, once that is out of the way, the next thing you need to be acquainted with is to understand how many atoms are present in each compound. For example, water has the formula H₂O. H₂O simply means that this hydrogen over here has a subscript, number 2. And number 2 is simply telling us that there are 2 atoms of hydrogen. Because remember, in our previous videos where we talked about the parts of a chemical reaction, we talked about the subscript, and that the subscript is the small number that is placed in front of an element. So this number 2 over here is actually a subscript, and it is telling us the number of atoms of hydrogen that is present in the compound. 2 atoms are present, and then we have just 1 atom of oxygen present. So once you are acquainted with that, you're ready to move to the next step. Now here is another example to buttress what we've just said. Here is carbon dioxide on the screen right now. Carbon dioxide has the formula CO2. Now CO2 has a number of things that it can denote from here. First of all, we have the symbol C, which stands for carbon, and it is showing us that there is just 1 atom of carbon present, and there are 2 atoms of oxygen present in this compound. So 1 atom of carbon is present and 2 atoms of oxygen are present in the formula CO2, which stands for carbon dioxide. So here is a tip. If you read a formula wrongly, you'll balance it wrongly. There are no 2 ways about it. So you need to be acquainted with the formula, because the formula is what you're going to be working with when balancing a chemical equation. So step number 2 is to use count boxes to track atoms. Okay, what are count boxes? Count boxes are simply written trackers that you use to analyze the number of atoms that you have. So here is what I mean. For example, now we want to balance this chemical equation, the equation that shows the combination of hydrogen and oxygen to form water. So the first thing to do is to count the atoms on both sides using a table. Now that table is going to be our count box. So let's draw out the table. So now we have the table that shows, first of all, the atoms. So let's separate the table using vertical lines. So we have our lines in place right now. So the next thing is to break the table out. So now that we have that in place, the next thing to do is to list out the elements that we have under this part of atom. So the first element we have is hydrogen. So let's write the name hydrogen down. So now that we've written it, the next thing to do is to count the number of hydrogen atoms that we have on the left hand side where the reactants are. So the equation shows us that we have H2 plus O2 giving us H₂O. Now this is the left side. How many atoms of hydrogen do we have? We can identify hydrogen over here having a subscript of 2, which tells us that hydrogen has 2 atoms on the left hand side. So if I'm to identify hydrogen, I will just simply say hydrogen has 2 atoms on the left hand side. On the right hand side, how many atoms of hydrogen do we have? You can see over here, hydrogen is also present with 2 atoms because the formula H₂O shows us that hydrogen has a subscript of 2. So both on the left hand side and on the right hand side, hydrogen is 2. So if I'm to identify them now, I would simply come and write it out. Hydrogen on the left hand side, we have 2 atoms, and on the right hand side, we also have 2 atoms. So hydrogen is balanced. However, for the next atom, which is oxygen, let's check out what we have. Now the equation shows us over here that oxygen has 2 atoms because of this subscript of 2. So let's identify it over here, 2 atoms. On the right hand side, however, you can see oxygen has just 1 atom because there are no subscripts identified there. So that tells us automatically that oxygen is just 1 atom present. So we have 2 on the left, 1 on the right. So we can see that oxygen is not balanced. So what is the thing to do now? So now that we know the one that is unbalanced, we have oxygen 2 on the left hand side and 1 on the right hand side. What do? We simply add a coefficient to make the atoms equal on both sides. So here is what we do now. This is the equation H2 plus O2 giving us H₂O. We want to make this oxygen equal to this oxygen. So we come here and add a coefficient of 2. Why did we do that? We did that because we cannot add a subscript of 2 like this. We are not permitted to change subscripts. That is a wrong procedure in balancing chemical equations. We are only allowed to add coefficients. Changing subscripts is changing the identity of the compound or of the element, and that is not permitted when you're balancing chemical equations. So let's write that out again. We have H2 plus O2 giving us H₂O. So we have a coefficient of 2 in front of H₂O to make sure oxygen is balanced on both sides. So if we check out our equation now, we can see that oxygen has 2 atoms on the left side and 2 atoms on the right side. So after each change in the coefficient, you have to make sure that you count the number of atoms that are present for each element. So now let's check out if hydrogen is balanced now. So on the left hand side, we have 2 atoms. On the right hand side, we have 2 atoms here multiplied by this coefficient of 2. 2 times 2 gives us 4. So hydrogen now has 4 on the right, but 2 on the left. So how do we make it balanced? We simply come and add a coefficient of 2 to make hydrogen balanced. So let's write out the full equation now. We have 2H2 plus O2 giving us 2 H₂O. This is our full balanced equation. Every element is now equal on both sides. Hydrogen over here has 4 atoms, and on the right hand side has 4 atoms. Oxygen here has 2 atoms, and on the right hand side also has 2 atoms. So what we simply did is to count the number of atoms for each element that was present, and then we changed the coefficients, which is the large number in front of elements and compounds, in order to make the atoms the same on both sides. I'm sure this lesson has been educative for you. If it is, please do well to like, share and subscribe so we can reach more people. So we've dealt with that example. Let's proceed to the next rule that we need to apply when we're balancing chemical equations. Rule number 2 says balance one element at a time. I know it's very easy as a student to fall into the temptation of trying to balance everything at once, but when you try to do that, it will confuse you. So it is important to balance one element at a time. Pick one, okay? When you pick that one, you count how many are on the left and how many are on the right, then adjust the number using a coefficient, and then you can move on to the next. So this example is what we have on the screen right now. We have C3H8 plus O2 giving us CO2 plus H₂O. So how many elements do we have in this chemical equation? We have carbon C, we have hydrogen H, and we have oxygen. So let's start with the first one, carbon. On the left hand side, let's identify how many atoms of carbon we have. You can see carbon has a subscript of 3 identified over here. So we have 3 atoms of carbon on the left. On the right hand side, how many atoms of carbon do we have? Carbon has no subscript, so automatically we have just 1 atom of carbon. So what does that tell us? We need to multiply this 1 by 3 in order to make carbon to be 3 on both sides of the equation. So when we do that, we will need to add a coefficient of 3. So let's do that very quickly. The equation now becomes C3H8 plus O2 giving us 3CO2 plus H₂O. I'm sure you saw how that change took place. We added a coefficient of 3 over here in order to make carbon equal on both sides. So now that we have done that, we will now go back to check the number of atoms for each element if they are balanced. We've taken care of carbon now, 3 on the left and 3 on the right. How about hydrogen? Hydrogen has a total of 8 atoms on the left hand side. You can see this subscript of 8 identified over here. On the right hand side, how many atoms of hydrogen do we have? Hydrogen has a subscript of 2. So we have 8 on the left and 2 on the right. So in order to make them equal, we'll simply multiply by a coefficient of 4. 4 times 2 will give us 8. So therefore, the equation now becomes C3H8 plus O2 giving us 3CO2 plus 4H₂O. At this point now, carbon is balanced, 3 on the left, 3 on the right, and hydrogen as well is balanced, 8 on the left and 8 on the right, because this 4 here multiplies these 2 over here. So the third element to pick now is oxygen. How many atoms of oxygen do we have? On the left hand side, you can see we have just 2 atoms of oxygen because of this subscript of 2. On the right hand side, how many atoms of oxygen do we have? You can see first of all that oxygen appears in 2 compounds. It appears in this 3CO2 and it also appears in this 4H₂O. So here now, 3CO2, you can see oxygen has a subscript of 2, and then this coefficient of 3 also affects it. So we have 3 times 2, that is 6 atoms of oxygen. And then we have oxygen over here. It doesn't have a subscript, so that is just 1 atom of oxygen multiplied by this coefficient of 4. 4 times 1 gives us 4. So we have altogether 6 plus 4, which is equal to 10. On the left hand side, we have 2, but on the right hand side, we have 10. So what do? In order to make 2 and 10 to be balanced, we multiply this 2 by 5. So now let's write out the full equation. We have C3H8 plus 5O2 giving us 3CO2 plus 4H₂O. You can see how the coefficients were introduced in this chemical equation, and you can see that we picked each element one after the other. We did not try to balance each and every one of them at the same time. No, we picked one, dealt with it, and then moved on to the next. If you're enjoying this video, please, I implore you to subscribe. Alright, now, so the next rule for balancing a chemical equation says to start with the complex molecules first. Alright, so when we say complex, we're simply referring to the larger and more complex molecules that have a higher number of atoms inside of them. So here is this example that we have on the screen right now. Let's go ahead and solve it step by step. We have Al plus HCl giving us AlCl3 plus H2. So now, looking at this equation, you can see that the most complex of them all is this compound over here, aluminium chloride, because it contains 1 atom of aluminium and 3 atoms of chlorine, altogether 4 atoms. So being the most complex of each and every one of the elements in this equation, we're going to start with this guy over here. So starting with this guy, we have 2 elements, aluminium and chlorine. On the left hand side, you can see that aluminium has just 1 atom, and on the right hand side, aluminium has also 1 atom. So aluminium is balanced. Now for chlorine, which is the second element, on the left hand side, you can see it has just 1 atom, and on the right side, you can see chlorine has 3 atoms. So in order to make 1 and 3 to be equal, we'll simply say 1 times 3. So now when we impute that into the equation, it now becomes Al plus 3HCl giving us AlCl3 plus H2. So you can see at this point now that aluminium is 1 atom on both sides, and now we have balanced chlorine to be 3 on the left and 3 on the right. So every point at which we change the coefficients, we're going to go back to check each atom and each element to see if the equation is balanced. So now let's check. For aluminium, 1 atom on the left, 1 atom on the right. For chlorine, 3 atoms on the left, 3 atoms on the right. For hydrogen now, we have 3 atoms on the left and 2 atoms on the right. So there is a problem. We need to balance hydrogen. So if hydrogen has 3 atoms on the left and 2 atoms on the right, how do we make them equal? We make them equal by simply saying these 3 multiplied by 2, and then this 2 over here multiplied by 3. That way, the left hand side becomes 6 and the right hand side becomes 6. So that coefficient of 3 that we put in front of HCl, we're going to change it to become 6 instead. And then over here, we're going to put a coefficient of 3. So that way, we have 6 atoms of hydrogen on the left and 6 atoms of hydrogen on the right. So let's do that very quickly. Now our equation becomes Al plus 6HCl giving us AlCl3 plus 3H2. So now hydrogen is balanced with 6 atoms on both sides. Aluminium is also balanced with 1 atom on both sides. So how about chlorine? Now at this point, chlorine is 6 atoms on the left and 3 atoms on the right. So now how do we make chlorine to be balanced? If we have 6 on the left and 3 on the right, we simply make it equal by saying this 3 times 2. So now the equation now becomes Al plus 6HCl giving us 2AlCl3 plus 3H2. So if you check now, you see that hydrogen is balanced, 6 atoms on the right and 6 atoms on the left. Chlorine is also balanced, 6 atoms on the left and then 6 atoms on the right as well. How about aluminium? Aluminium is just 1 atom on the left but 2 atoms on the right. So if we have 1 on the left and 2 on the right, how do we make them equal? We make them equal by simply using this 1 and multiplying it by 2. So doing that now, our equation now becomes 2Al plus 6HCl giving us 2AlCl3 plus 3H2. So at this point, every atom and every element is balanced. If you check it out now, we have 2Al plus 6HCl giving us 2AlCl3 plus 3H2. If you check for aluminium, we have 2 atoms of aluminium on the left, 2 atoms for aluminium on the right. For hydrogen, 6 atoms of hydrogen on the left and 6 on the right as well. Chlorine has 6 atoms of chlorine on the left, and then we also have 6 atoms of chlorine on the right because these 2 affect these 3 to make it 6. So we finally balance this chemical equation to be 2Al plus HCl, 6HCl, giving us 2AlCl3 plus 3H2. I'm sure you saw the steps that we took in balancing this chemical equation. We started with the complex one and then moved on to the ones that were less complex. So the next rule in balancing a chemical equation is to leave hydrogen and oxygen for the last. Why did we say that? Because usually hydrogen and oxygen are almost always involved in multiple compounds, okay, especially in combustion and acid reactions. They usually do not stand alone. Most of the time they are present in compounds, so that's why we balance them last. They are easier to adjust once the other elements are in place. Now here is this example on the screen, this equation over here. So we're going to start with carbon and then we'll move on to hydrogen and then we'll move on to oxygen. That's what the rule simply says. So first things first, we have carbon. On the left hand side, carbon has just 1 atom. As you can see identified over here, carbon does not have a subscript. On the right hand side, you can see carbon also doesn't have a subscript. It is 1 on the left and 1 on the right. Carbon is balanced. So now we can move on to hydrogen. So for hydrogen now, you can see it has a subscript of 4, which tells us that it has 4 atoms on the left. On the right hand side, you can see hydrogen has a subscript of 2, which tells us that there are 2 atoms. So in order to make them equal, you simply say multiplied by 2. So that tells us that we add a coefficient of 2 in front of H₂O. So the equation now becomes CH4 plus O2 giving us CO2 plus 2H₂O. At this point now we have balanced hydrogen, 4 on the left and 4 on the right. So now we move on to oxygen. Oxygen has 2 atoms on the left because of this subscript of 2 identified here. 2 on the left. On the right hand side, how many atoms of oxygen do we have? You can see 2 atoms of oxygen here because of this subscript. So that's 2 plus another atom of oxygen here which has a coefficient of 2. So that gives us 4 atoms of oxygen on the right. So in order to make that equal, we simply multiply the left side by 2. So that tells us that we're going to add a coefficient of 2 in front of this oxygen over here. Now this chemical equation now becomes CH4 plus 2O2 giving us CO2 plus 2H₂O. So at this point now, we're going to check and verify if all the atoms are balanced. On the left hand side, we have one carbon atom, and on the right hand side, one carbon atom. On the left hand side, we have 4 hydrogen atoms. On the right hand side, we also have 4. On the left hand side, we have 4 oxygen atoms, and on the right hand side, we have 2 here and another 2 here because of this coefficient of 2. So it is balanced. So this equation becomes our final and balanced equation. This is it over here. So now that we have seen the next rule, which is to leave hydrogen and oxygen for the last, let's proceed to the next one. The next rule says to use a pencil or an erasable marker. Okay, so now this is an underrated advice that many people do not take seriously, because number one, you're likely to try different numbers before getting it right. If you've been paying attention throughout this video, you'd notice that we changed coefficients a number of times. There was a time when the coefficient was 3, and after a while we changed it to 6. So we needed to have something that was erasable so that it will not be messy. So using a pencil makes it easier to erase and retry without making a mess. Because let's face it, in chemistry, which is a scientific subject, it's okay to make mistakes. Albert Einstein, who founded the light bulb, did not get it at his first trial. So we also will make mistakes. So just make those mistakes in pencil so you can erase them when you find out the correct stuff. So here's a quick reminder of all we've been saying since the commencement of this video. Never you change a subscript. Changing a subscript is like changing the identity of a chemical element or compound. So only change coefficients. Next is to always count each atom before and after you change a coefficient. Use count boxes or tables. They help you see clearly and keep track of the number of atoms of each element that you're balancing. And then finally, practicing makes it easier and faster. It's just like learning to ride a bike. The more you practice, the more adept you get at it. So now that we have seen all these rules, okay, here is something by the way. If you decide to change the subscript of a compound instead of the coefficient, for example, water is H₂O. If you decide to change the subscript in this case for oxygen, you decide to change it to H₂O2. What you have just done is that you've changed this from water to hydrogen peroxide. If you change it, you're no longer dealing with water. You have made something new. So that's why it's a no-no for changing subscript. Think of subscript like names. It's just like changing the name of your friend. You can't just rename your friend just like that. It's like changing their identity. So that's what happens when we're balancing chemical equations. So here's a quick recap for the 5 golden rules that we saw when balancing chemical equations. You do not change subscripts. You are to balance one element at a time. Start with the complex molecules, leave hydrogen and oxygen for the last, and then use a pencil. The trial and error is part of the learning process. So here are some practice questions from simple to complex that we're going to be dealing with. So we have this first question on the screen right now. Let's deal with it. First things first, we're going to start with the more complex compound, which in this case is this guy over here. So we have 2 elements inside this compound. We have ion Fe, and then we have oxygen O3. Okay, so now for the first element, ion, how many atoms of ion do we have? On the left hand side, just 1. On the right hand side, we have 2. So to make them equal, we simply multiply the left by 2. So this equation now becomes 2Fe plus O2 giving us Fe₂O₃. So at this point now, this equation is yet to be balanced, because even though this ion is balanced on the left and on the right, oxygen is not balanced, because we have 2 atoms of oxygen on the left and 3 atoms of oxygen on the right. So how do we make them balanced? We simply say this 2 multiplied by 3 and this 3 multiplied by 2. So that means we'll add a coefficient of 3 in front of oxygen here and put a coefficient of 2 in front of this compound over here to make oxygen balanced. So the equation now becomes 2Fe plus 3O2, giving us 2Fe₂O₃. So now let's check out each element to see if they are balanced. Oxygen is balanced with 6 atoms on the left and 6 on the right because of this coefficient of 2 that affects the subscript of 3. How about iron? We have 2 atoms of iron on the left and we have 4 atoms of iron on the right. So what does that tell us? We need to change this 2 to 4 by multiplying it by 2 so that there can be 4 on the left and 4 on the right. So doing that, our final equation now becomes 4Fe plus 3O2, giving us 2Fe₂O₃. That way this equation is finally balanced. We have 4 atoms of iron on the left, 4 on the right, 6 atoms of oxygen on the left and 6 on the right. I'm sure you saw how we balanced this equation from A to Z. So let's move on to the next example. The next example that we have on the screen is the reaction between magnesium and hydrochloric acid to produce magnesium chloride and hydrogen gas. So now, first things first, we're going to start with the more complex compound, which is this one over here. So now, starting with this, we have 2 elements inside, which is magnesium and chlorine. On the left hand side, we have just 1 atom of magnesium. Same goes for the right hand side. So magnesium is balanced. How about for chlorine? On the left, we have just 1. On the right, we have 2 because of the subscript of 2 present. So that tells us that we need to now add a coefficient of 2 in front of HCl so that chlorine can be balanced. So now that chlorine is balanced, the next thing to check is if the other elements are balanced as well. Magnesium is 1 on the left and 1 on the right. Chlorine is 2 on the left and 2 on the right. Hydrogen is 2 on the right and also 2 on the left because of this coefficient of 2. So all the elements now have been balanced. So the balanced chemical equation becomes Mg plus 2 HCl, giving us MgCl2 plus H2. All the elements in this chemical equation have been balanced. This is the balanced chemical equation. So next up on our list is this chemical equation on the screen. I want to leave this as an exercise. I want to see the smart ones among those watching. Of course, everyone is smart, okay? But I want to see those who would be the first to pick out the right answer for this question on the screen right now. So do well to let me know what you think the answer is in the comment section below, and I'll be waiting to receive it. So here is the summary of all we've been saying. When you're balancing a chemical equation, first things first, count the atoms carefully. Next, start with the metals or complex compounds, and then leave hydrogen and oxygen for the last, especially when they're in water or acids, and then use the lowest possible whole number coefficients, and then finally double check your final counts before calling the chemical equation balanced. Did you enjoy every bit of this video? It It was a pleasure for me putting this out for you guys, and I'm sure you enjoyed it as much as I did. So up next on this series, we're going to be looking at the practical applications of balancing chemical equations and some of the tricks you need to be acquainted with. It's been a pleasure hanging around with you guys, and I'm so glad you stuck around till this point in this video. If you did, thank you. And I'm asking once again, if you've not subscribed, do well to do so, and we'll be able to reach more people. Up until I come your way, my name's David, the billionaire teacher, and over here what we do is to take the mystery out of chemistry so you can make history. I'm looking forward to seeing you in the next video, and I'll see you there.